Hello and welcome to the third session of MCNP. Today we're about to introduce the MCNP input file. The basic four cards of MCNP input file are title card, in which it includes the title of your code. MCNP does not read this line. Then we have a block called the cell card. Then you have a blank line. It implies that the cell card is done. We have another major block called surface card. And finally, we have here another blank line. It also implies that the surface card is done. And finally, we have what we call the data card. Cell cards takes its information from surface card and data card. What's the concept of having a cell? Let's say we have some sort of core which consists of different assemblies or similar assemblies. This core is considered a complex structure. This is the assembly. Consists of ferro rods. That's what we call a cell. But this is a complex cell. Therefore, we have to make a cell for the fuel, a cell for the gap, a cell for the clad, and then a cell including all of this. Therefore, the cell cards consists of several basic inputs, several minimum inputs, salaries, cell card. Basically, cell card is dividing my complex geometry into several cells. What does a cell card consist of? First, we have cell number, and we have material number, and we have the density of this material. Then we have the position. relative to the surface code. Then we have the importance. Those are the minimum requirements of cell code. See, those two are taken from the data card, and the position is taken relative to surface code. Then let's talk about surface card. Surface card is responsible for surfaces making such geometry, or the surfaces used, manipulated to describe certain geometry or certain cell or certain position. Difference between cell and surface. Surface is a 2D, cell is 3D. What does surface card consist of? Surface card mainly consists of surface number, which will be used in the cell card to imply the position, and then surface symbol, and then surface parameter. Then we have to go to the data card. Till now, using cell card and surface card, you have really done nothing with MCNP. You have used it like AutoCAD. The data card is what you really want to calculate using the MCNP. What you want to do using the MCNP? Data card. It includes material which is taken into the cell card, and tallies, also K code if you're calculating criticality. Then let's have a simple example about a field rod. What does a field rod look like? We can simplify it as a fill and clad. Fill, clad. This is a plan view. And considering the elevation view, here it is. Fill and clad. And then I prefer to use this method of writing code. First we have the title card, which is, let's say, fuel rod. Then we have write C like that. That's a comment. So card, and we have here surface card. Okay, what surface do I use to describe a fill rod? Obviously, I have a cylinder. Its axis is Z axis. Another cylinder. Its axis is the Z axis. Before I have you say give this surface number 100 CZ. Let's say the radius of the fissile column is 0.35 centimeters. Then may I have 200 CZ 0.5 centimeters. Then this surface is called 100. This surface is called 200. Okay, now what I've done is that I have drawn an infinitely long two cylinders. Then I need to close them like that, maybe with a plane perpendicular on the z-axis, and then another plane perpendicular on the z-axis. Therefore, I have 300 plane perpendicular on the z-axis. Let's say if I have my origin in here, then this will be, let's say, 30 centimeters, and here negative 30 centimeters goes with x, y, and z. These planes perpendicular to the z-axis at positive 30. Sorry, 30. I have 400 plane perpendicular to the z-axis at negative 30. Then I come to the cell code. First, cell number is 1, turn number, let's give it number 10. Then the density, let's say, if I'm to make this cell 1 and this cell 2, then let's say density of uranium 2 to the 35, 18 gram per centimeter cube. When I put a negative sign, then I'm talking about gram density, and I'll describe it later. Therefore, here I have to describe the position. Describe the position, I'd say negative 100, which means inside the surface 100, which is a cylinder, and also below the surface 300 and above the surface 400. Then I have importance of neutron equal 1. How about the 300 and 400? First, if I leave a space here, it means intersection. It means that it's inside the 100, and below the 300 and above the 400. So this is a negative sign below the 300. Okay. How about the negative and positive things? Negative on an enclosed body like this means inside. Positive means outside. How about the planes? Planes we describe it by using where you're standing and where you're going. Let's say this is the place I want to describe. I'm standing here at this point, moving in the negative direction of z-axis. Then it's negative, the surface. My position is in the negative direction of the surface. How about here? I'm going to the positive direction. Then it will be positive of the surface. Okay, then let's describe cell 2, which is the cladding. The cladding will be, let's give another material. If you say that cladding is aluminum, then it will be 2.7 gram per centimeter cube. Then it will be outside the surface 100 and inside the surface 200 and below 300 and above the 400, and of course importance of neutron equals 1. Now we've described the whole geometry. But remember in video 1 we said that we track the neutron path till it absorbs or the path is terminated. Therefore I need a place where the importance of neutron is 0. This place will be outside my area of attention. Therefore it will be a void. We'll give it another cell. It will be a void. It will be outside the 200. We'll say that this is 200. Outside the 200. Here, if I set the material number 0, therefore there is no density. Or in the positive direction of the 300, or in the negative direction of 400. And importance of neutron equals 0, so it can terminate the history. Now I have cell card, surface card. What I'm waiting for is data card. Let me take eraser and erase this line. Thank you. Here, data card. First I have to describe the material. M10 will be, sorry, this is the code for U235. You can find it in the manual volume 1, the code of each isotope. The one which means I'm talking about gram fraction or weight fraction. I have M11. We said it's aluminum, so it's 13027, also negative 1. You notice here the material is written in ZZAAA to describe each isotope. Now let's talk about the density and weight fraction and atomic fraction. Density. Density have two ways to express it. Gram density or number density. Gram density, if a negative before the density, then it's gram density, and unit is gram per centimeter cube. If I leave it without negative, then it's number density or atomic density, and its units is atom per centimeter dot bar. And of course we know that bar equals 10 to the power 24 centimeters square, used to describe the cross section. Here regarding the material fraction. Material fraction, we have two ways to express this fraction also. Weight fraction or atomic fraction. Weight fraction uses negative sign, and atomic fraction no negative sign, it's positive value. Example, let's say if I have weight fraction 5% enriched uranium, then therefore 92 to 35 negative 0.05, and space, that's how it's written, 92 to 38 0.95. Atomic fraction, say that's an example. Atomic fraction example is like water, we have H2O, therefore 1001 0.67 and 8016 0.33. Thank you very much. The next video we're talking about simple geometrical configurations regarding card and surface card and how to manipulate both of them. Thank you very much.